have they're covered in plastic covers so you can't see the coils. But Ian and I took the covers off so you can see what's inside. This is called a birdcage resonator. And it's called a birdcage resonator because it has these copper strips that are linked by other copper, and these go all the way around. So yeah, V naught in this direction. And the V1 field that the birdcage resonator produces is in that direction to the right-hand side. It's across the bore. V1 is across the bore. Because of the way in which this resonator operates, it's staying all the way around. Copper strips and held together by an informer. These are the tuning capacitors. The whole things here are ceramic capacitors. This is called a high-pass birdcage resonator, and when it's fed with radio frequency through these cables, it generates it generates a V1 field across the cylinder. So that then would be perpendicular. It would lie like this in the scanner. This is a head coil, so the patient's head is going in here. So this would actually be used to transmit the radio frequency pulses and to receive the NMR signals.
What is the coil that generates the?
Well, so an MR scanner has an RF coil built into it, a whole body sized RF coil built into the structure.
So it's supposed to be perpendicular to the beam.
Yes, that would usually be a birdcage resonator as well, just a bigger one to take the whole body. So that can be used to transmit and receive, but usually it's just used to transmit. However, when you image the head, you usually use a transmit-receive coil like this. So this would, in that case, the whole body RF coil would not be used, it would be disconnected. And this would be the coil that would be used both to transmit the V1 pulses and to receive the signals back. And the reason you would use a different coil is that you always want, especially the coil that's receiving the NMR signals, to be as close as possible to the part of the body that you're imaging. Because if you just slid the patient into the scanner and only used the whole body RF coil, you can transmit RF pulses through it, and that's no problem. But when the signals are produced in the head, some of them would be lost. They wouldn't be picked up by the whole body RF coil because the reception, the process of receiving the NMR signals from the precessing magnetization in the head is much more efficient if the pickup coil is close to the head. So that's why you'd use a head coil like this. Or that, for example, is a breast coil that's covered still on. So if you're imaging the breast, then the patient would lie on that, and that would be used only for receiving them. You would use the whole body RF coil to transmit the pulses, and that would receive the signals. And you can see it's shaped in such a way that it's most efficient for breast imaging. Some other coils here, so this would be the neck coil. And then these ones are surface coils. So these can be, and this is the simplest possible surface coil, which is just a loop of wire with a tuning and matching circuit. So this would be used for receive only, but it can be placed anywhere in the body that you're wanting to image, although it has to be placed perpendicular to V naught. Oh yes. So So from this you can image the whole spine at the same time. Well, this is for 1.5 Tesla, so that would be 64 megahertz. You can see that one there, 64 megahertz. For proton, yeah, for proton.